The problem is, a rocket lifts off at a speed of 20 meters per second and lands back on the ground after 4 seconds. Find the maximum height and final velocity just before the rocket touches the ground. Now what times will the rocket be 10 meters off the ground? First we're going to start off with a diagram. So we know that the final time is 4 seconds, and the initial velocity is 20 meters per second. We also know that since the final time is 4 seconds, then halfway, the time is 2 seconds. And also, at the top there's a slight pause, so that means that the final velocity for halfway is 0 meters per second, and then the initial velocity for the other half is also 0. And also, because of gravity, there's acceleration of negative 9.8 meters per second squared on both sides. Now we're going to solve for the maximum height. In order to do this, we're going to use the displacement equation, x equals vit plus 1/2 at squared. And what we know from the problem is that the initial velocity is 20 meters per second, and the final time is 4 seconds. And since we're solving for the max height, we're going to use this side of the rocket. So the time where the max height is going to be 2 seconds because it's halfway. And the acceleration, because of gravity, is negative 9.8 meters per second squared. Now we're going to sub in the values. So we have the initial velocity of 20 meters per second times the halfway time of 2 seconds plus 1/2 the gravity acceleration, negative 9.8 meters per second squared times 2 seconds times 2 seconds, which is also the halfway time. And we're going to use unit analysis to cross out the seconds. And we're left with displacement equals 40 meters minus 19.6 meters. And that equals 20.4 meters. And we can fill that in right here. Now we're going to find the final velocity just before the rocket touches the ground. So that'd be like right around here. To do this, we're going to use the acceleration equation, which is acceleration equals final velocity minus initial velocity divided by time. Using simple algebra, we're going to rewrite this to final velocity equals initial velocity plus time times acceleration. So first we're going to start off by plugging in the numbers. So for this, we're going to use the second half of the rocket. So the initial velocity is 0 meters per second because of that slight pause at the top. So we have 0 plus the time of 2 seconds times the acceleration of negative 9.8 meters per second squared. And we're going to solve, and that equals 19.6 meters per second. Then we're going to use the unit analysis to cross off the units. And we can write that right here to be 19.6 meters per second. Now we're going to find the time at which the rocket is 10 meters off the ground. So in order to do this, we're going to use the displacement equation, x equals vit plus 1/2 at squared. However, since there's 2 times where the rocket is going to be 10 meters, right here and right here, we're going to turn this into a quadratic. So we're going to rewrite this to be t squared, acceleration times 1/2, plus time times initial velocity minus displacement equals 0. And in order to solve this, we're going to have to use the quadratic formula. So t equals negative b, that's b, plus or minus the square root of b squared minus 4ac. That's a, and that is c. All over 2a. So when we write this, we're going to write it as negative 20 plus or minus the square root of 20 squared minus 4a, which is negative 9.8 divided by 2, times c, which is the displacement of 10, because that's what we're trying to solve for. And we're going to divide that by 2 times negative 9.8 over 2. And when we solve this, the 2 times, you're going to get 2 times because it's squared. It's going to be 0.58 seconds and 3.49 seconds. So the 0.58 seconds, since that's sooner in the rocket's travel, it's going to be 0.58 seconds right here. And on the other side, it's going to be 3.49 seconds. Now we're going to recap everything we just solved for by drawing it on our diagram. So first we have the initial velocity, of 20 meters per second, and the time of 4 seconds. And again, we have the time of 2 seconds for the halfway point. Because of the slight pause, we have the initial velocity of 0 meters per second for the second half, and the final velocity of the first half of 0 meters per second. And what we solve for the final velocity, and that is 19.6 meters per second. We have the second half acceleration of negative 9.8 meters per second squared because of gravity. And also, gravity is still present in the first half, so we have negative 9.8 meters per second squared in the first half also. And what we solve for the 10 meters, and the time at that. So we have 0.58 seconds and 3.49 seconds. We also solve for the max height, and that was 20.4 meters.